Welcome back to the Scotti-BYTE channel, and this is Scott. Well, this one took me a few days because I wasn't exactly sure what I was going for as I started to test out various things. But in any event, I came up with a video that I originally wanted to call Virtualized Virtualization. And that sounded like too much of a tongue twister, so I pretty much settled for Virtual WSL. So, in my previous video, Secure Shell SSH from Windows, I showed how the Windows subsystem for Linux could be installed on Windows to provide a virtual Linux shell. WSL uses a simple init process that does not use the systemd service, and so therefore many standard Linux services do not run. There is a GitHub project called distro-d that solves this problem, and it does so by creating a simple container that runs systemd as an init process and starts the WSL sessions from inside of that container. This allows snap, SSH, LXD, and other types of services to easily run like they would on a server. So we're going to learn how to configure distro-d. Also, we are talking about things about WSL and your network. Well, by default, WSL2 instances are assigned an address from a private NAT that is inside of your Windows 10 or Windows 11 machine. Although you can connect to your WSL2 container from your Windows host, that WSL2 instance is generally not reachable from your LAN. So recall from my past videos that a bridge is a switch that connects to networks. We will learn how to create a bridge in Windows 10 or Windows 11 between your physical Ethernet device and the WSL network device. And this will give Windows an address on your LAN via the bridge and another address on the LAN for WSL via the bridge. So therefore, you'll be able to SSH to your WSL instance from anywhere on your network. So what is this good for? Well, WSL is helpful for prototype testing, but not really for production. Microsoft has issues with persistent bridge assignments between reboots. And of course, there's the issue with systemd and their init process not providing complete support, which we provide somewhat of a workaround with distro-d. And so we're going to show that you can reach your WSL instance via SSH, as I mentioned earlier, from your LAN with this configuration. And we're going to demonstrate LXD inside of WSL2 and also the limitations of that because of the way that Microsoft decided to implement it. But it does work, and I look forward to time in the future where the WSL2 shell will actually closely approximate what we get from a server. But in any event, I'll show you some of the things that we've done on the channel in the past in terms of implementing a LXD instance. And so, although you can back up, I should say, WSL instances, and you can also create new ones, they have an import and export command. It really doesn't appear that multiple WSL instances can run concurrently. So, if it's any big surprise here on the channel, and it probably isn't, I really don't run Windows. So I ran Windows for about 20 years, and I ran it when I was working professionally, obviously, and supported it all the time. But in about 2007, I ran off to a Linux-only environment and left Windows in the rearview mirror. So basically, I use Windows now in order to support other people, and generally it's in a virtual machine. So you're going to be surprised to learn in this tutorial that my Windows 11 that I've been showing off the last couple of times is actually running inside of a QEMU virtual machine, which is configured with Linux Virt Manager. The Windows 11 WSL2 is a virtual instance of Linux nested inside of Windows. And in the video, I show how to create virtual LXD containers inside of that WSL2. So the LXD containers are virtualized 3 levels deep in my demonstration. And I think that's just kind of cool. So let's go see how this actually works. In my last video entitled Secure Shell from Windows, I was actually using this QEMU virtual machine named Win11-QEMU. And here I have the graphical interface to Virt Manager where I can start that machine. But what we're going to do first is I've taken a series of snapshots with the command virsh snapshot, and here I did a snapshot list, and I've done 4 snapshots so far, and the original snapshot I forgot to give it a name, so by default it names that snapshot according to some number. So since I'm kind of at an endpoint in my configuration, I'm going to do another snapshot, and I'm going to call it final. So you do that with the virsh command, where you say virsh snapshot-create-as -- the name of your virtual machine, which is Win11-QEMU, a space, and -- name as final. So we hit enter, and that's how long it takes to create a snapshot in QEMU. And if you're not using QEMU, which is a great open source hypervisor software, and you're on Linux, you might consider that as a great alternative to using either VirtualBox or something like VMware. Now, if we list our snapshots, you can see that I have an additional snapshot called final. And what we want to do next is we want to go ahead and revert to that numbered snapshot with the command virsh snapshot-revert Win11-QEMU and then the number. And this will take a little bit longer because it has to go back in time through all 4 of the previous snapshots. So now that we have our Windows 11 VM in the state that we want it in, we can go to the Virt Manager screen, click Open. It'll open a console window. We can say Start, and then we can say View Full Screen and see how long it takes to boot the QEMU instance. Now I go ahead and type in my password. As a review from last time, we have stock Windows 11, so we're going to go ahead and click on the Start button. We'll type PowerShell, and then we'll right-click PowerShell and say Run as Administrator. We'll provide it privilege, and when it comes up, we'll do a WSL -- install, and this will go off and install WSL with an Ubuntu machine. Now that Windows has gone through the requisite number of reboots, we can go ahead and sign back in, and the installation process will complete by asking us to initialize our new Ubuntu WSL instance in a moment. I provided the Linux username Scott, and then it asks me for a password. I retype my password, and WSL is installed. The first thing that I want to do is a sudo apt update && sudo apt upgrade to bring our instance up to date. So now that our Ubuntu 20.04 WSL instance has been fully updated, the first thing I want to do after that is do a sudo apt install net-tools. And the reason I like that is because it has a very nicely displayed version of ifconfig. And you can see here that I'm running at 172.26.116.8. Now, if I bring up a command shell in Windows and I do an IP config, you can see that it has an address on my main network of 172.16.1.106. So you can see clearly that this 172.26.116.8 is actually in a private NAT network that is not reachable from my LAN. The second thing that I want to show you is that if we do a sudo systemctl status, the system comes back and says system has not been booted with systemd as the init system, and so it can't operate, failed to connect to the bus, host system is down. So a lot of the commonly started services use systemd to start them with the systemctl command are unavailable to us, so starting a lot of those types of services is not possible. In the last video, I showed that we can use commands like SSH, so we can SSH out to admin at 172.16.1.57, which is one of my NAS units, and we get a prompt and we get a password, and I can sign on to that system. So that's good for outbound, but there's no capability to do inbound connections, and the reason for that is because of this private address. Well, if we have to do ifconfig here, this private address that we've got here, 172.26.116.8. So we have to deal with a way to fix the private address issue, and we have to deal with a way to fix the issue of not being able to run services. In watching my channel at other times, you notice that I frequently use LXD containers. So if we do a LXC list, you can see that LXC is not installed, and it says that you can go ahead and install it. Now we're not going to do that because I can tell you right now it's going to fail because it's not going to be able to start the service that's required for the LXD daemon because it relies upon systemd. So let's go ahead and download and install systemd, and I'm going to move my terminal down here, make it wider, and also make it a little bit longer, and we'll go ahead and do the systemd installation command. With any luck, I can go down here and do an edit paste, and there's a curl command that brings the systemd installation script down from GitHub. So now it's downloaded the systemd installation script. The next step I have to do is a chmod plus x to make the script executable, and the name of the script is install.sh. Now that we've done that, all we have to do is do a sudo /install.sh with the keyword install. It will download some other pieces, and then it goes ahead and says installation is complete. One final step that we have in the installation of systemd is this command that allows it to start on Windows boot, which is something that we want to have, and all of these notes will be in the show notes. So we execute that, and it says it requires admin privilege, hit enter to proceed, and it's talking about admin privilege in Windows, which now it comes up, we say yes, and then they want me to enter my password once again. And that's all there is to it. It says distro D will now start automatically upon Windows startup. In order to make our distro D work, we're going to have to go ahead and exit out of this. And then we'll go ahead and launch another command shell. And we'll type in WSL. And when we enter WSL, we should now be able to do a system or a sudo system ctl status, enter our password, and you can see that now we're getting a listing of systemd services that have been started on the system, which was our goal. Now if we do a sudo lexi or sudo lexi list, it'll think for a little bit, and the lexi service is a standard, and you can see that it comes up and it is actually running. In order to get our lexd properly running, we have to do a sudo lexd init, and no, we don't want clustering. Yes, we do want a new storage pool. The name of the storage pool will be the default, so I'll hit enter. And the name of the backend to use for the storage, we're going to let this default to BTRFS. The default in LXD would normally be ZFS, but because we're running in this WSL2 shell, it does not support ZFS. So do you want to create a new pool? Yes, I do. Would you like to use an existing block device? No, I do not. Size in gigabytes, it defaults to 50 gigs, which is just fine. Would you like to connect to a MOS server? No, we do not. Would you like to create a new local bridge? And the answer to this has to be no, because unfortunately it will not work with the bridge, but we'll go ahead and try the default of yes just to show you how it fails. And we want it to be want the bridge to be called LXD BR0, and what IPv4 address should be used, and auto is correct. What IPv6 address should be used. WSL2 does not fully support IPv6, so we want to type in none here. We hit enter. It says, would you like LXD to be available over the network? For right now, no. And would you like stale cached images to be updated automatically? Yes is a good answer there. I hit enter and it said, would you like a YAML file to be printed? And no, I really don't need one. I hit enter, it thinks for a while, and it comes out with this error message about the LXD interface because it can't create the bridged interface correctly. And I've not really yet determined what exactly causes this. So now we're going to run the lexd init command once again, and this time we're going to take the more or less the same things. We're going to say, no, we don't want to use clustering. Yes, we want to create a new storage pool. Yes, we want it to be default. Yes, we want it to be BTRFS. Yes, we want to create a new pool. No, we don't want it to be using an existing block device. The 50 gigabyte default is fine. Would you like to connect to a MOS server? No. Would you like to create a local bridge device? This time we answer no to this question. Would you like to use LXD? Would you like to configure LXD to use an existing bridge or host interface? The answer to this for right now is going to be no. And would you like it to be available over the network? Well, since there's no network, no. And would you like stale cached images to be updated automatically? Yes. And you want the YAML file printed? We say no. and this time it completes successfully. So the next thing that I want to do is I want to do a sudo usermod -a capital G LexD Scott, and that will add Scott to the LexD group, so I won't have to use sudo commands whenever I issue the lexc command line to manipulate my LexD containers. In order to make that take effect without logging off and logging back in, I do a new group spelled NEWGRP LexD, and then I can type groups, and I can see that the LexD group has been added to the beginning of the list. So now that LexD has been properly initialized, I can do a lexc list without the sudo command, and it comes back and says that there are no LexD containers because we haven't created one yet. So we're going to use this command to create the container. And again, remember that in Linux, capitalization counts. So I have a lexc launch Ubuntu :20.04 test will be the name of the container, -- profile equals default, and the default profile gives it the root file system. And I have a flag called boot.autostart equals to true. And what that does is when WSL starts up, when Windows boots, it will go ahead and start this container likewise. So I hit enter, it says it's creating the test, and it says it goes ahead and creates it, but it says the instance you are starting doesn't have any network attached to it. To attach a network to an instance, use lexc network attach. If we do a lexc list, you can see that the container is up and running, and we can attach to it with a lexc exec test bosh, and we are connected to it. However, this container is not reachable over the network and cannot communicate with the network as of yet. Since we couldn't create a LexD BR0 bridge device from LexD init, we're going to have to do it in a different way. So I'm going to exit out of my test container, and then back at the WSL2 instance, I'll remind you that if I do an ifconfig, you will see that we are still running at the NAT address of 172.26.116.8. And one of the things that we want to be able to do is we want to be able to bridge the WSL network to the main network so the WSL instance can be remotely reachable from other systems on our LAN. So for right now, we're done with WSL2. So let's do an exit command and another exit command and yet another exit command because we've got pretty deep there, and another exit command to log out of our shell, and we're back to the Windows prompt. So if you go Control Panel and you bring up Networks, Network and Internet, in Network and Internet, I would like to have the ability to be able to change my network configurations. And so I'm going to say Network. And this is really interesting because if you look at this list, it brings up this long list. But if you type network space connection, this list still doesn't really change to what we want. If we make connection plural with connections, then we have view network connections is what we're after. I don't know why Windows feels the need to bury these critical screens so deeply, but that's how you get to it. So right now, this Windows 11 instance has one Ethernet device that happens to be called Ethernet Instance 0, and it's out here on the network. So our end goal is to take this Ethernet device for Windows and bridge it with the Ethernet device that is being used for our WSL instance, all except for the fact that you don't see our WSL instance Ethernet device. So in order to fix that, we click on the Start button again, and we type in Windows Features, and we get this option for Turn Windows Features on and off. If you click on Turn Windows Features on and off, you'll get this screen here, and it will list all the features that we can turn on after a requisite amount of time. Okay, so we want to turn on Hyper-V. Put a check mark in Hyper-V, say OK. It will search for the required files. It will install them. And in true Windows fashion, we'll once again reboot the system. Now that the system is rebooted, I log in once again. And now we want to go ahead and click the Start button, type in Hyper, and we're going to go to Hyper-V Manager, but we're going to right-click on Hyper-V Manager and say Run as Administrator. When Hyper-V Manager comes up, we want to go ahead and highlight our virtual machine, which is Win11-QEMU, except that it's not a virtual machine. This is really the main host here. And we want to go over to the right-hand side where it says Virtual Switch Manager, and we click on it. In Virtual Switch Manager, you can see WSL, and WSL says it's only operating on its internal network, which is why WSL has a private address and not a public address. So we want to click on External Network, and then we want to click on Apply. And it says pending changes may disrupt network connectivity. That's fine. We say yes, and usually this fails the first time. Once this fails, we go ahead and click on Cancel. We go back into Virtual Switch Manager. We click on WSL. We click on External Network. We click on Apply again. We say yes, and this time it works because everything in Windows always works the second time. So now we can do an OK to close Virtual Switch Manager, and we can go ahead and exit Hyper-V Manager. Now if we click on the Start button and we go to Control Panel again, and Control Panel Network and Internet, and we type in Network Connections, making sure to make it plural, and we click on View Network Connections, you will see that there is an Ethernet instance and there is also a virtual Ethernet instance for WSL. Now, if we go ahead and type in CMD and we do an IP config on it, you will see that it has the address of 172.16.1.106, which is what we expected. And if we type in a second CMD and bring it down over here and go into WSL, in WSL, if we do an if config, we will see that it has the address 172.21.196.3, which is still a NAT address. So another thing worth mentioning is whenever we reboot and we come back up, you'll notice that that connection is missing. And one of the best ways to fix it is to go back into Network Control Panel, hit Network Connections, and now of course we only see one of them. We don't see the second one, but if we right click on this particular one and go down to Properties and scroll down to the bottom, you want to uncheck Hyper-V Extensible Virtual Switch and then do an OK. At that point in time, make sure you click away from this so you don't have the Ethernet instance highlighted, and at that point in time we can type in Hyper-V again, and we right click on Hyper-V Manager, Run as Administrator, And when it comes back up, we can go into the virtual switch manager. We can go highlight WSL, go to external network, do an apply, do a yes, and this time it successfully completes. Now, we do an OK from there. We do an OK for Hypermanager, and you can see that it is bringing up that network. Now, at this point in time, I think that maybe Hyper-V has already bridged the two networks, even though you would think you would have to do a bridge. Let's find out, because my mileage has varied and your mileage may also. So instead of actually doing the bridge, we're going to bring up the command prompt, and at the command prompt, we're going to do WSL, and I don't expect to see anything different when I do an ifconfig command. And you can see that we're still running at the private address. However, if we are in fact bridged, then I may be able to actually demonstrate that. And one of the ways I can do that is I can do a sudo IP addr flush dev eth0. So ETH0 is the name of the Ethernet device that is inside of the WSL instance. We do that, we type my password, and we get a prompt back, and it doesn't look like anything has taken place. And then we do a sudo dhclient ETH0, and that asks DHCP to go get a new address, and it comes back immediately. Now, if we do an ifconfig, you will see that we have an address of 172.16.1.141, and that is in fact on the main LAN. So what we were doing actually worked. Now, the other thing is, if we want to make SSH acceptable, or accessible, not acceptable, accessible, we're going to do a sudo apt remove -- purge for open SSH server, because this is just the simplest way to do that. And then when that's completed, we go ahead and bring back up the same command, and we do a sudo apt install of OpenSSH server, which will guarantee to refresh all of the keys and get the server installed again. As a reminder, if we do an ifconfig, we have address 172.16.141 in our WSL instance. If we do a command here and we do an ipconfig, which is the Windows command, you can see that it's running at 172.16.106. So the address is actually different as expected and desired. So now that we have the two separate addresses, I'm going to bring a terminal over here from my Ubuntu host, which has nothing to do with this VM. It's just displayed on top of this VM. And I'm going to do an SSH to 172.16.1.141, which is the IP address of the WSL2 instance that we've now bridged to the main network. I hit enter, I accept the fingerprint, I type in the password, and it signs on to the WSL2 instance, and you can see the prompt win11-QEMU and the username of Scott. And the reason that I didn't put the Scott name up here was because I have a Scott account locally and the remote account is Scott, so it was able to log into it. So that shows you that we now have our main instance bridged as we desired, so that the WSL2 can be accessed from outside of the Windows machine. So now, since we're reachable from the main network on the WSL2 instance, if we do an ifconfig here, you will notice that we have the ETH0 adapter with that address on the main LAN of 172.16.1.141, and we have a loopback connector. So it's only safe to assume that we would be able to do what we can do with a normal Linux instance, and that would be to go and create a NetPlan file and add a bridged interface. So in order to do that, we're going to go to, well, hopefully edit paste, but it's not bringing it in here. So let's see if we can do better with this. Let's do a sudo apt, no, let's do a sudo /etc/netplan. So netplan is the file that can update the network configuration. And keep in mind, we wouldn't have been able to run netplan without distro D because it requires a systemctl service be started. So now I'm going to edit netplan. I'm just going to call it 01-network.yml because I'm not coming up with anything real creative. And it works better when you put nano in here. So let's try that. The magic of live video, right? So then we have that in there. So now we have to go get our netplan file that we want to configure to change our network over. And it's really very simple. Hopefully we can paste this in here, edit paste, and that worked for whatever reason. So what we have here is we have renderer is equal to network D. So we don't have network manager. Network D is simpler. And then ETH0, as you saw before, is the internal device. And I say, yeah, go ahead and get a DHCP address. And then we're creating a new device called BR0, which is a bridge. And we're also DHCPing it. So I save this thing out and I do a netplan. Well, actually, we need to do a sudo netplan apply. And it executes. And now if we clear the screen and we do an if config, you should notice a new bridge device. And of course, you do not. Okay, this gets interesting. So over the past couple of days, I've done a lot of testing on what we actually have here network-wise. And at various times, I have been able to get this netplan file to actually work here. And this time I can't get it to work because if I do an if config, I usually end up with just my ETH0 and my loopback adapter. From time to time, though, if you ever start and stop the WSL instance, for some reason, you have to do the sudo IP address flush device ETH0 and another sudo DH client ETH0 in order to get a new address from the network. And of course, anytime that you reboot the system, I'll show you what you need to do here pretty much. You see we have our two devices there. And if we do a shutdown restart and we reboot Windows, when we reboot Windows, we are not going to have the two connections anymore. And in fact, if we go into our WSL instance, I don't believe that we're going to have connection to the main LAN again. But we'll test that theory here in just a minute. So we log in and we do a command and we do a WSL. Waits for a minute while WSL starts. And we do an if config. And you can see again that we're running on another private address 172.18.122.210. And you'll find here that if I do a sudo IP addr flush dev ETH0, give it my password, and I do another sudo DH client ETH0, and I do another if config, you notice it's not even coming back from the DH client because it's hung. And the reason it's hung is because it's not bridged back to the main network. It has no connection to the main network at this point in time. So in order to fix that, and this is kind of amazing, after every reboot, and I think I mentioned it earlier, you got to go into Control Panel, Network, and then you have to say Network Connections with the S. You have to select View Network Connections. You have to right-click on this guy, go down to Properties, scroll to the bottom, and uncheck Hyper-V Extensible Virtual Switch and do an OK. Then you have to click away from this. Go ahead and leave that screen up. And then we have to type in Hyper-V, right-click Hyper-V, run Hyper-V as administrator, go over to Virtual Switch Manager, highlight WSL, click on External Network again, because of course every reboot makes it an internal network, and do an apply, and do a yes. And of course it fails because we showed you that it fails over and over. So we come over here again, we right-click this guy, we scroll down to the bottom, it is off, this is good, life is good. You have to completely exit the network connection screen, I imagine. And then you have to do an apply, and you do a yes. And again, it fails. So we cancel this, and we get out of Hyper-V completely. And we realize that we need to exit this because we're talking to that device. And now that everything's been exited properly, we can go into Control Panel. Oh, let's see, not Control Panel. Let's go into Hyper-V. By the way, this doesn't operate the same time every time, which makes it a really great production system. Not. So you go into Virtual, Switch, click on External, click on Apply, click on OK. This time it works, and the reason it works is because the stars were aligned and the temperature and humidity are just correct. So this is a really good thing. Now we can go ahead and type in Control Panel. And when we type in Control Panel, we can go to Network and Internet. We can type in Network Connections with the S. The magical option View Network Connections becomes viewable again. And there we are. We have our virtual Ethernet for WSL up and our regular instance, which indicates that they're actually bridged, although it doesn't really seem like it, but they are. And now we can launch our WSL instance. When it comes up, we do an ifconfig, and of course it still has a private address, and the reason it has a private address, or actually it has no address in this particular case, then we can do a sudo let's see. Let's do a sudo dhclient ETH0, and it should be able to get a new address at this point in time. And it seemed like it came back, so we do an ifconfig, and magically we're back onto the main network at 172.16.1.67. So this is how it works. This is how it works now. Unfortunately, things aren't great. In our test when we did a LXC list, you can see that I was able to create a virtual container just fine, and it's called test. I can even start the container, do an LXC start test, and it says container's already running. When you do a reboot, things always mess up here because it doesn't shut them down properly. So you have to do a LXC stop test and then do a -F on the end to force it to stop. And then it will come back reasonably quick. And then we can do a LXC start test. And then we can do a LXC list. And of course, the darn thing never really gets an IP4 address because of the aforementioned problems with Windows dealing with the bridge device and not handling it properly. I tried turning off the Windows firewall thinking that might be it, and it really wasn't. But anyway, at this point in time, I can certainly do alexc exec test bosh, and we're in there, and I can certainly do an IPA, and as you can see, this instance here has an ETH0 device, and it gives the MAC address, and it gives a local IPv6 address, but there's no IPv4 address being granted to this thing, and it's primarily because of the fact that I wasn't able to create my bridge device. My bridge device should have created through NetPlan, and in a couple of tests I did yesterday, I got that bridge device to create itself at this level. So when I did an if config inside of WSL, I actually had an ETH0 and a BR0. So that's the good news. Now, when I tried to associate that with LexD, which I have other things on the channel that talk about bridging, the association worked, but it never really did get an IPv4 address, or when it did, it didn't hang on to it for whatever reason. Now, one of the reasons that that could be the case is it might be my level of virtualization. Mind you, it probably isn't a really good demo to be running a QEMU virtual machine of Windows 11, a virtual instance of WSL2 inside of it, and then a virtual instance of LexD inside of that. So for you people that have physical Windows 11 machines, all of what I'm saying might actually work the first time. The caveats, however, are that certainly you need distro D in order to be able to run your systemctl commands to get systemd services to be up and running, as you noticed. And then you also need the bridge capability. And the other downside is the fact that, unfortunately, when you reboot your Windows 11, for whatever reason, Hyper-V Virtual Switch Manager will halfway delete the switch, so it's no longer out there anymore. So you'll have to reestablish the switch, and then you'll have to go inside of your WSL instance and do a sudo IP address flush dev ETH0 and do a sudo DH client ETH0, and then it will get an address from outside your network. So this whole thing right now is something that honestly Microsoft really needs to fix. If they want WSL to be a development environment, which is what they're advertising it as, it needs to be a reliable development environment. So in summary, KVM is a powerful virtualization hypervisor for Linux. We discovered that my QEMU VM for Windows 11 actually runs pretty well. And in the previous video, we saw how well WSL2 runs inside of Windows 11, but at that time you didn't know that Windows 11 was a QEMU VM. In this tutorial, we installed distro D to allow systemd services to be managed, and we also changed the Windows default Ethernet device to be a bridge. We also nested LexD inside of WSL2, inside Windows 11, inside of QEMU. We learned that the Windows implementations have some shortcomings, and we also learned some workarounds. Watch my other 30 plus videos on my channel that go into depth on LexD and LexD networking. Anyway, that's it for today. Please subscribe and like to the channel and hit that notification bell, and we'll see you next time.